Hello students, good morning, good evening and good night, depending on which time which you are going to observe this lecture. Welcome to the first lecture on solutions. This solution chapter is included in your class 12 chemistry syllabus, and in this chapter we will learn several things. Number one, we learn some definitions of the solutions. Secondly, we learn the types of solutions. Then we learn different types of expressions of the concentrations that which we can apply, and this is related to already we have studied in the class 11 and the first chapter, that is basic concept of the chemistry. First chapter we have already studied about this, how do we able to express the concentration of the solutions. Then we learn about different type of factors which is going to influence the solubility. Here we will concentrate only the binary solutions, that we will understand what is binary solutions, and we also learn how all those factors that is going to influence the solubility, that is solubility, type of solubility, nature of the solubility, or the temperature or the pressures, that we are going to learn. And then we will also discuss about the vapor pressure. When there is two volatile liquids present in a solution, then we will see how this is going to be affected, how the composition is going to affect it, that we all learn. And afterwards we will learn also some colligative property and osmotic pressures also. So these are all the contents in the class 12 syllabus. This is the first lecture. In this lecture we will learn 2-3 very important things. And so this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First we are going to discuss some important definitions of the solution chapters. Some important definition means that we are going to discuss first what is solutions. The definitions of solutions. What do you mean by solution? Solutions is basically a homogeneous mixtures, two or more components. And this homogeneous mixture means what? Homogeneous mixture means that there is a uniformity in terms of the compositions, in terms of your properties of these solutions. That is why it is called homogeneous. Whatever you take any material, sample of the solution, you will find the same properties and same composition. That is why it is called the homogeneous mixtures of the two or more than two components. We will be concentrated on the binary solutions where there is a two components is there. One components that is having, that we will now discuss. So we can learn, we can say what is solution. Solution is, it is a homogeneous mixtures of two or more components. Homogeneous means, that is already discussed, it is basically the uniformity in the properties and the compositions. And here we are talking about the binary solutions. Binary solutions means we are talking about binary solutions. What is binary solutions? Binary solutions is basically the solutions which having the two components. The two components having the binary solutions. One component which is having which is present in the solution at the higher amount, it is called the solvent. So these two components, one is solvent, one is called the solvent, means which is having the higher amount, which is present in the higher amount, it is called solvent. And solute, another component is solute, that is lesser amount. Simple things we can say that is a sugar solution. In the sugar solution you will see that water is the solvent and the sugar is the solute. So you understand what is solution, what is binary solutions, and what are the components. And the physical state, another thing that is very important thing, that is the physical state. Physical state of the solution is basically depends on the physical state of the solvent. Physical state depends, we can write, depends on the solvent. Depends on the solvent. Here another thing that we understand, we must know that the particle size in the solutions. Solutions having the particle size, that is the molecular size. So three number things we can say. The particle size. Particle size, that will be the molecular size. Particle size is molecular size. And it is having the diameter, that is 10 to the power 9, not more than 10 to the power 9 meter. Not more than, less than 10 to the power minus 9 meter its size. So the particles which is observed, which is in the solutions, cannot be separated out, cannot be by a simple way. So, and the solutions is different type of solutions in terms of its type of solvent. We can say when it is contained the water, you will call it is the aqueous solutions, and which contains the solvent is other than water, we will call it the non-aqueous solutions. Now we are going to discuss a very important thing, that is on the basis of the physical state of the solvent, the solution can be classified on the physical state. On the basis of physical state of the solution, we can classify the solutions in different ways. That is, number one, that we can say gaseous solution. First we understand gaseous solution means the solvent will be always gas. Solvent will be always gas, and we will understand we can change the solute. When we change the solute as a gas, suppose gas is a solute and gas is also a solvent, at that time the solution will be the gaseous solution. The examples of this, oxygen in nitrogen gas, that is what you observe in the air. The air having, you can find that is the nitrogen having the higher percentage as compared to the oxygen. So gas in gas. Gas solvent in the gas solute in the gas solvent, we called this is a gaseous solutions. Also we can say gaseous solutions, that is liquid in gas, that is the another classification. Example, as you can see, liquid in gas, that is chloroform. You only mix chloroform with N2, chloroform with N2. This is also the example of the gaseous solution, and here having the solute is the liquid. Now the third one, solid. It is also a gaseous solution, but Here what is there? Difference is the solute. Solute is solid and solvent is gas. And other time the example is the camphor. Camphor is basically a solid. Camphor in nitrogen. So you can say here nitrogen gas is a solvent, it is same. Whereas we are changing the solute, gas, liquid and solid. In the same way that you can see liquid. Liquid solution means its solvent will be liquid. Solvent will be liquid and liquid. Solvent will be liquid. Okay. Now gas. Gas is a solution. Solute. This is a liquid solution. Gas is a solute, but liquid is the solvent. At that time, you will find the example is when oxygen dissolved in water. Oxygen dissolved in water. So we will call this is a liquid solution where gas is a solute. Another example that we can see, another variety, that liquid solute, liquid is solvent. At the time the example is the ethyl alcohol. We can write alcohol in water. Okay, alcohol in water. This is the another example. And then solid is solute and liquid is a solvent. It is a very common version that we are day to day life we are seeing. Where there is a two liquids, it is only one liquid over there. Sorry, this is liquid is solvent. So solid and liquid. Solid is solute and liquid is a solvent. Is a very simple example, sugar solution. Sugar solution, you can see this is an example of where the solute is solid and liquid is the solvent. There is a second variety we understand, and there is a third variety, that is the solid. Solid also, here solid will be the solvent, and three cases we are discussing solvent here. Okay, now you can see in the gas is a solute and solvent is the solid. At that time the example, that is a solution of H2 in palladium. Solution of H2 and in palladium. Second, that is liquid in solid. Liquid in solid, you can see that is the amalgam of Ag, mercury, in the sodium. This is the example, amalgam in of Ag in sodium. Okay, and liquid, and last is solid. Solid in solid, that is different alloys. You will find that this is basically the solutions of the solid in solid. As for example, copper dissolved in gold. Copper dissolved in gold. This is an example. So we understand different types of the solution on the basis of their physical state. Okay, so this example of the things will give you a clarity how what is solute and what is solvent. There will be not a confusion. The solute is always a minimum quantity present in the solution and solvent is a larger quantity, and the physical state of the solution always being governed by the physical state of the solvent. So you understand all the things. Now we are going to understand how do we able to express the composition of the solution. Composition is solutions is expressed by its concentration. There is a two type of concentration term that we can see. One that is the qualitative and another that is the quantitative. Qualitative that you can see where suppose we are talking about a solution which is dilute. Means there is a lesser amount of solid particle. When we say the solution is concentrated, means it is concentrated means it is having the higher amount of the solid. But this type of representation, or you can say descriptions of the concentration of the solutions, is not enough. It always going to create a confusion of relativity. You cannot able to reach a conclusion. That is why another type of solutions, another type of description of solution is the quantity type. Quantitative type solutions, you will also find that there is a two types. One is volume based and other is weight based. That we can see volume based as for example where the volume term will be there. That is percentage weight by volume. Second thing, that is the molarity, normality, formality. All those description of the concentration of the solution has been in the volume based. There is on. So concentration terms, we will discuss the quantitative based, quantitative concentration based. That we are going to discuss. That is basically two things that we are that is the volume based. One is volume based. Volume based is basically that is the molarity, then normality, formality, by percentage by volume, percentage by volume. These are all the volume based. Another thing that is the weight based. Weight based, or we can say the mass based. Weight based, that is mole fraction. Mole fraction is the way that we can able to express mole fraction. Then percentage by weight, percentage by weight, then molality and PPM, parts per million. All those are basically the weight base. So let us understand one by one. First, let us understand what is molarity. Molarity is basically represented by capital M. It is the number of moles present in 1 liter of the solution, 1 liter volume of the solution. So molarity, we can write the moles of solute, moles of solute, moles of solute divided by volume of solution in liter. BUL means volume, SUL means solution. So this is the molarity. The moles, now moles of the solute. If 1 mole present, then 1 molar, 2 moles, 2 molar, 0.5 moles, 0.5 molars. In the volume of the solution in liter, that we have to always understand. Then next is normality. Normality is represented by capital N, and it is the gram equivalent. One new terms, that is gram equivalent of solute. So number of gram equivalent of the solute divided by volume of solution in liter. This is called the normality. Then molality. Molality is represented by small m. You can understand. Molarity is capital M. Molality is small m. Molarity means what is? Now it is the moles of solute divided by mass of solvent in kilo. Mass of solvent in kilo. So here you can see moles of solute. This is all the weight base, and mass of the solvent in kilo. In 1 kilo of solvent, the presence of the moles, number of moles, gives you the molality. Whereas in the molarity, it is the number of mole presence in the 1 liter of the solution. So both these things that you need to understand. Here one thing that is giving the gram equivalent. What is gram equivalent? Let us understand. Gram equivalent. Gram equivalent is basically for the acid, for the base, and for the salt. Both the things we will going to understand. It is basically the molar mass of acid. For in case of acid, molar mass of acid divided by the basicity. That is for the acid. For acid we will say this. Okay. Molar mass of base divided by acidity. That is for base. And gram equivalent molar mass of salt. So when talking about the salt, molar mass of salt divided by total positive valency of metal. Valency of metal atom. Which is positive valency of metal atom. This is for the salt. So these are the gram equivalent. What is gram equivalent? The molar mass of the acid, as for example H2SO4, its molar mass is 98 and its basicity is 2. So what will be the gram equivalent? Gram equivalent will be the 49. That is going to discuss, that is the percentage by mass. Percentage by mass, that is being expressed by W by W. It is the mass of solute in gram divided by mass of solution into 100. This means what? This means the solute amount of the solute in gram present in the 100 gram of the solution is called the percentage by weight. This is percentage by weight. And another term, that is percentage by volume. Percentage by volume, that is again the mass of the solute in gram, mass of solute in gram divided by volume of solution, in milliliter into 100. Means what? The amount of solute present in gram in the 100 milliliter of the solution, it is called percentage by volume. And both these things are applicable for those solutions where the solid has been dissolved in the liquid. But if the liquid is dissolved in solid, at that case the percentage mass will be same, but percentage by volume, that will be different. Here the term mass of the solute will be replaced by the volume of the solute. Volume of the solute in milliliter present in the 100 millimeter of the solution. So these are all the very important terms that we discussed. Now the another term that is very important, two terms that we will discuss, that is the mole fraction, and another we will now discuss the mole fraction. Mole fraction is the very important way that we can able to describe the concentration of the solution. Mole fraction for the binary solutions. For the binary solution, we understand it is having the two components. Binary solution having two components. So having two components. And one component, suppose component 1, having the moles is N1. And another component having the mole is N2. So what is the mole fraction? Mole fraction we can write, that is, suppose if this is x1, it is N1, the moles of this component 1, that is N1, divided by total mole. And the mole fraction of another component, suppose it is H2, it will be given by N2 by N1 plus N2. And when we add this x1 plus x2, it will be N1 by N1 plus N2 plus N2 by N1 plus N2. This will be always 1. So you understand, for the binary, in this type, if you have more than two components, that you can able to calculate is mole fraction. In the mole fraction, you have to know the moles of the each and every components. After that, you will have the total moles, and with the ratio of the moles of this particular component that you want to calculate divided by total moles of these components will give you the mole fractions. So mole fraction is a very, very important way that you can able to express the concentrations. Second, that is the last that we will use, the PPM. PPM is nothing but it is called parts per million. Parts per million, it is a PPM. When the solute present in the solution is a very trace amount, very less amount. As for example, we can take example 1 liter of sea water. 1 liter of sea water contains 6 into 10 to the minus 3 grams of dissolved oxygen. So this is a very less amount. For this less amount, this term has been introduced, that is ppm, parts per million. What do we mean by this parts per million? Let us understand. Parts per million, the gram of the solute presents in the million grams of the solutions. Million gram of the solutions. So you can write ppm. ppm, that is mass of the solute, mass of solute in gram, divided by mass of the solution, mass of solution into 10 to the power 6. 10 to the power 6 is for the millions. Means millions amount of the solute in gram present in the millions parts by weight of the solutions. It is called the ppm, parts per million. Now we can calculate the ppm of this, where this amount of the O2 has been dissolved. Here you can see what will be this ppm. That we put this in this formula. The mass is giving 6 in 10 to the minus 3 solution, and 1 liter 1033 gram, suppose. So it will be 1033 gram into 10 to the power 6. It will be coming around 5.8 ppm. This term has been utilized giving the million of the weight. 1 million gram of this solution will have this amount, and it is found as this. For today's lecture, this is the first lecture. In this first lecture, we have discussed some very basic things in the solution chapter. In the second lecture, we will discuss about some important relationships, right? How do you relate with the mole fractions of the solute with the molarity, with the molality, or what is the relationship between the molarity and molality, that we will discuss. And we also discuss one thing, that which is more concentrated, 1 molar solution or 1 molar solution, that we discuss. Also, you understand all the points that I want to say. If you have any doubts, you can comment in the comment sections for better clarity. Thank you very much for watching. See you in the next lecture.